Hello everyone, this is 16.3 Reaction Rate Law by Chem With Me. The rate law expresses the relationship between the rate of a chemical reaction and concentration of the reactants. So think of it as it's relating two things, the rate and the concentration. All rate laws must be determined experimentally. And the symbol K is a specific rate constant, which is a numerical value that relates the reaction rate and the concentrations of reactants at a given temperature. The specific rate constant is unique for every reaction. Notice the exponents m and n in this equation. The reaction order for a reactant defines how the rate is affected by the concentration. It's determined by m and n that I just pointed out before. Let's take a look at this equation. The rate equals KH2O2. The reaction is in the first order because it has no power. When there's no power, that means the power is 1. Or when there is no number, that means the power is 1. So the rate changes in the same proportion as the concentration. And this is normally found in decomposition reactions, which is when you have one product and it breaks down into two or more. Its graph is always a straight line because it's directly proportional. And let's take a look at this equation. It's not decomposition because there's not one reactant. Decomposition always has only one reactant. So the reaction order and the coefficients are not related. You can't say that that m and n are 2 and 2 because they are the coefficients. So the equation actually is KNO2 or to the power of 2 and H2 to the power of 1. If H2 is doubled, the rate doubles. But if NO doubles, the rate quadruples because 2 to the power of 2 is equal to 4. So both sides are quadrupled. The overall reaction order is 3 because for NO it's 2 and H2 it's 1. So you add them to find the overall reaction order. The method of initial rates determines reaction order by comparing the initial rates of a reaction carried out with varying reactant concentrations. Initial rate measures how fast the reaction proceeds at the moment when reactants are mixed. If you get a question with a table like this, how to solve it is to look at the concentration of A or B and choose two equations in which the concentrations are the same, so you can cancel them out and find the power. So you pick two equations or two rows, and you put the rate, which is the last column, like let's say we're going to pick 2 and 3, because for A, they are both 0.2, the concentration. So you put 4 times 10 to the power of negative 3 over 16 times 10 to the power of negative 3 equal to the concentration of A, which is 0.2, and to the power of M, because it's unknown, the power or the order, and multiplied with the concentration of B, which is 0.1, over 0.2, which is taken from the second row. And then you cancel out the powers, and then you continue working with mathematical steps, and you'll reach the answer. Okay, so there are 3 tables that represent orders. If it's a horizontal straight line, it's in the 0th order. And if it's a diagonal line, which is directly proportional, it's first order, because the coefficients are directly proportional to the order. And if it's second order, it will become very curved. It's a curved graph because the rate is doubled. So, okay, so if the concentration is 3, you'll times it by 2, and it will increase very rapidly instead of steadily increasing or gradually increasing like the first order. Okay, so there are 3 reactions. Decomposition, which is one product, which is A, and it breaks down into B and C, and it's usually, not always, the rate order is usually 1. For a one-step reaction, it will mention so in the question. The reaction order is the coefficients. And for other reaction, the reaction order is not at all related to coefficients. And you have to use the method of initial rates to find it, which I just explained in the previous slide. Thank you all for listening and watching my YouTube channel, and thank you for all your